Hi everybody, this video will introduce the concept of recursion, and it's intended for complete beginners. So if you already have an understanding of how recursion works and you're confident with your understanding, this video is not for you. However, you might want to stick around and enjoy some pink bunnies. What we're going to do today is look at the concept of recursion. This is when a function calls itself until an end state is reached, and then the function will stop calling itself and produce some kind of result. Now that may sound like complete gobbledygook to you at the moment, so we're going to look at an example of how recursion works, and because we're all complete beginners, we're going to look at a very simple example. The example we're going to look at is we're going to design a function which will count or calculate the number of ears that a certain number of bunnies have. So here we have 5 bunnies, and we should quickly be able to calculate that there are 10 ears. We're going to look at how to solve this problem recursively. Now, as I said, recursion is when a function calls itself until an end state is reached. So let's look at this concept in pseudocode. I'm going to design a function called bunny ears, and this function takes an integer as a parameter. This is the number of bunnies that we're going to do the calculation on, and it returns an integer. This will be the total number of ears. So let's start coding. The first thing we need to consider is the end state that will get us out of the recursive call. We need to get out of it, or we're going to be stuck in an infinite loop of recursive function calls. We don't want that. We need to find a way to get out of it. So this is the end state for this particular problem. If numbunnies, which of course is our parameter here, is the same as 1, then we're simply going to return 2, because we know that 1 bunny has 2 ears, so that seems quite logical. So this is our end state. Now let's look at the recursive element of the problem. We're simply going to return 2 plus bunny ears numbunnies minus 1. Okay? Now very interestingly, here we have the same function as the function we are designing. So this line here shows me that this code is recursive in nature, because this function calls itself. Okay? So let's imagine that numbunnies is equal to 2, and let's come into the function. If numbunnies is 1, well, that's not true, so this code here doesn't run. So we jump down to this return statement. We return 2 plus bunny ears 1. 2 minus 1, so that's 1 now. Ooh, we've called the function again. So we go back up to here, this is the recursive bit, and we call bunny ears 1. This is now 1. If numbunnies is 1, yes it is. Okay, we've reached the end state very quickly. Then we're simply going to return 2. Now it's still a little bit difficult to visualize what the heck is going on, so we are going to look at a third page. But before we do that, I just want to write very quickly a computer program which will call my function bunny ears. Very simple computer program. Let's call it total ears is assigned bunny ears. We'll call the function, and let's say we've got 5 bunnies. So this is my computer program. It's going to call this function, and it's going to send it the number 5 as the number of bunnies as the start. Okay? So let's have a deeper look at how this works. So this is my initial function call. Now we know that when numbunnies is not equal to 1, we haven't reached an end state yet, we're going to return 2 plus bunny ears 4. Okay, do you remember that? If numbunnies is 1, well, it's not, it's 5 at the moment. So we jump to here, return 2 plus bunny ears 4. Okay? So, this is the current situation. This function call actually returns 2 plus bunny ears 4. Now we don't know what bunny ears 4 is. The function is busy calling itself again. So this becomes 2 plus bunny ears 3. Now we don't know what bunny ears 3 is yet. This has to go through its own function call. So we're kind of trapped in a loop here. The code hasn't resolved itself to a value that we can assign to total ears yet. That was trapped in this recursive loop. We're still in it. Bunny ears 3 returns 2 plus bunny ears 2. We're still trapped in the loop. Bunny ears 2 returns 2 plus bunny ears 1. We're still trapped in the loop. Bunny ears 1 returns 2. Yes! We reached the end state. We've reached the end state. Okay? So this call to bunny ears 1 simply returns the value 2. So we can replace this code here with, or this call, with the value 2. So we can see the call to bunny ears 2 actually returns 2 plus 2. So this is the equivalent of 4. So we're now working our way back out of this recursive series of calls. We're now going back in the other direction because we reached the end state. So the call to bunny ears 3 returns 2 plus 4, which is 6. And the call to bunny ears 4 returns 2 plus 6, which is 8. And the call to bunny ears 5, we've finally made it all the way back to our starter function call here, is 2 plus 8, which is 10. And that, folks, is how recursion works.